Alright, so welcome to our video on substitution. This is going to start to branch into some somewhat new territory for us. So far we've worked with one equation. We'll graph one equation or solve for a variable with one equation. But as you get older, we start to work with more equations or more concepts at the same time. So when it comes to substitution, it's just a method of basically working with more than one equation at the same time. So I'm going to skip forward a little bit to talking about what is substitution. So you can use a system of equations, and it says here for movie earnings, but really anytime you want to find the intersection of two different sets of data, you can use substitution. So one method of finding an exact solution is substitution. The second one is called elimination. We're not quite working with that yet, so let's just start with substitution. So when necessary, you're going to solve for at least one equation for one variable. So your first goal anytime you're substituting is to get one variable isolated by itself. The second step is to substitute the resulting expression from step 1 into the second equation to replace the variable and then solve. And the third step is to substitute the value from step 2 into either equation. This seems a little bit confusing without a true example yet, but the long and short of it is your goal is to isolate one variable, substitute it into an equation, and hopefully at the end your answer should always be an ordered pair. And an ordered pair is something like x, y, right? Or something like 2, 3. So x is 2, y is 3. So that's really what we're getting at. So let's look at our first example. So in our first example, we see that y equals 2x plus 1, and 3x plus y equals negative 9. Well, here we're actually super lucky because we already have a variable that's been solved for, and that's y. If you notice, this entire equation is saying that y equals something else. And down here, in our second equation, we have y by itself. So if y equals 2x plus 1, we can actually substitute in 2x plus 1 wherever it says y, because what y equals means is this is the same thing. So because 2x plus 1 is the same thing as y, we can actually substitute this into the second equation and write it as 3x plus, and then I always add a parenthesis, 2x plus 1, just to show myself where the substitution occurred. And that equals negative 9. So now it's pretty simple. All you've got to do is solve for x. We've got 3x plus 2x. They're on the same side of the equation, so we add them. So we have 5x plus 1, which equals negative 9. Then we want to get x by itself, so we just do our basic equation solving here. And we find that x equals negative 2. So if x equals negative 2, excuse me, we can just write it over here. X equals negative 2. I'm just going to erase to do our second step. So now that we know that x equals negative 2, that's great, but we still have to find out what y is. So now my goal is if I know what x is, I can put that anywhere in either equation that says x. I personally am going to substitute into the first equation. So substituting x is negative 2 into the first equation, I'm going to write y equals 2 times negative 2 plus 1. And all I'm doing is substituting x in where it says x in this equation up here. So that means that y equals negative 2 times 2 is negative 4 plus 1. So y equals negative 3. So if y equals negative 3 and x equals negative 2, as a coordinate pair, this can be written in the form xy, or basically negative 2, negative 3. And this should be your answer. I'm going to try another one with you. Again, we have another situation where we have y equals 4x minus 6, Then we have 5x plus 3y equals negative 1. So, if you notice, we already see that y equals something. And down here, we have a situation where we have y. So I'm personally just going to substitute in. So I have 5x plus 3, and this is where the parentheses really come in handy. So it's going to be 3 times the entire concept of 4x minus 6, which equals negative 1. So now you might already be seeing what we have to do next. So I'm personally just going to show you using these arrows. Distributive property. If we have these parentheses, we immediately want to go to distributive property. So I'm just going to rewrite this as 5x plus, and then you see 3 times 4 is 12x. 3 times negative 6 is negative 18, which equals negative 1. Then we have 5x plus 12x, which are on the same side. So that'll become 17x minus 18, which equals negative 1. Then I'm going to add 18, 17x equals 17. So that means that x equals 1. Simple enough, right? So x equals 1. So now that I know that x equals 1, my second step is to figure out what y equals. So I'm going to take either equation. I personally am just going to keep choosing the first one and substitute it back in. So now I've got y equals 4 times, then I'm substituting in 1 for x since they're the same thing, and subtracting 6. So here we've got y equals 4 minus 6, or y equals negative 2. So if y equals negative 2 and x is 1, I find that as writing it into coordinates, we have 1, negative 2. And that's our final answer. Alright. With the third one, I'd love for you to take a pause here and try to solve it yourself. In the event that you need some help, obviously press play and we'll see what you need help with. So hopefully you've solved it by now. Basically, let's do our first step. If we notice, we've already seen that y as itself equals this entire concept. So we can substitute that in. So we're going to substitute back into our first equation. So we have 2x plus 5 times the entire concept, 3x plus 10, which equals negative 1. So with that knowledge, we have 2x plus 15x plus 50, which equals negative 1. Once again, we have our two x coordinates, or our two x terms, excuse me, on the same side. So it'll become 17x plus 50 equals negative 1. Alright, so now we're almost done with this section. We have to do our subtraction of 50. We find that 17x equals negative 51. So that means that x is negative 3. So once again, my goal now is to solve for our other variable y. So solving for our second variable y, we just have to plug in. So I'm going to go back into my second equation this time actually. Again, it's entirely up to you. You can choose whichever one's more comfortable to you. But I'm going to have y equals 3 times negative 3 plus 10. So y equals negative 9 plus 10, or y equals 1. So y equals 1, x is negative 3, so we can rewrite this as negative 3, 1. And that should be your entire answer. We're going to do one more and then we're going to stop. So once again, pause here, try to do this one out yourself, and then click play when you're ready to continue. So here, we've got x equals y minus 2. So again, your variable that's isolated will not always be y. So in the event that it isn't y, we can still just do substitution in, but this time, we see that x by itself equals this concept. So now, we're just going to do some basic substitution. We find that 4 times y minus 2 plus y equals 2. Again, we've got our friend distributivity. So we have 4y minus 8 plus y equals 2. Then on the same side, we have a positive 4y and a positive 1y. So this becomes 5y minus 8 equals 2. Add 8 to both sides. 5y equals 10, which means that y equals 2. And again, we're going to use pretty much the exact same concepts of substituting back in. So I'm going to substitute back into the first one, and I have x equals, my y is 2 minus 2. So that means that x equals 0. You've got our two solved coordinates here, so my answer is 0, 2. Alright, thank you for watching. I hope this helps.